guys only have 2 people.
Kevin's not here.
Kevin. You knew exactly what I was like. Yeah, here we go. Yesterday, where did we leave off? My board was wrong yesterday. Oh, it's still wrong. Stink. I didn't fix it. It's fine online. It's fine in the calendar. It was fine in the Google Classroom deadline. It was just awful on the board. I think I just wrote it down, assuming it was due in one day, and I was totally wrong. So it's due tomorrow. Hey, what else is due tomorrow? You've had more than a week, but hey, maybe that's something you can use 0 period for, yeah? 0 period stamp sheet. Isn't October week 5 shaded out? So this week is the makeup week. Does that make sense? So be making up your stamps, you're turning in your stamp sheets on Monday and getting November, December stamp sheets Monday as well. All right, okay, let's bust out this section. We get to kind of, you got to take a breath last night. You got to not finish the entire assignment last night. So let's see why I felt like we needed an extra day. And AJ, it was like number 58. It's like the example that you just wrote down in your spiral. Here we go. Cool kids. What is the antiderivative rule, integration rule to use for number 32? Power rule, because we can rewrite this as x to the negative 2. Yeah? Gavin this morning was asking me about some different antiderivatives and trying to think through if they give you, oh my boards are being used. If they give you something like the integral, I know, just think green, ignore the rest. F of x times g of x, not minus, times. Can I use properties? If they tell me the integral of f and the integral of g, can I just plug it in and say, yay, he's 3, he's 5, 15, please? No. If this is a sum or a difference, can I split it up? Yes. If it's multiplication, there is no basic property for that. And Gavin was asking, okay, well, what are the other, are there other types of integrals? Is there a rule for multiplication that we can do? And I said, hey, there's this thing called integration by parts. We're going to learn it. We are going to learn how to do harder integrals. But now is not the time. Now is thinking basics. Power rule. Got it. Rewrite it. There's no quotient rule. There's no product rule for integration. But we can do the power rule. So therefore, power rule tells me add 1 and divide by, right? X to the n plus 1 over n plus 1. Did you guys get negative 2 over x, right? From negative 2 to negative 1, because adding 1 is negative 1, dividing by negative 1. Got them. Plug and chug, and we end up with, wait, which one do we plug in first? F of b. I don't even know. F of b minus f of a. Sorry, every year when I have to reorient my brain. F of b minus f of a. So therefore, negative 2 over negative 1 is positive 2 minus, careful, minus positive 1, which is just cool? Cool. Okay, so what we missed out on yesterday was, I was talking about how we had not talked about any antiderivative rules technically in our book yet. And so I have a lot of antiderivative integral rules coming on the next pages. But first of all, you guys like the first sentence? Once again, I copied and pasted from the book because I thought it was good, but doesn't it look like a repetition? At the risk of repeating ourselves. Oh well, it's important. It is difficult to overestimate the power of the simple equation. Hey, it's the other FTC, whatever part you want to call it, doesn't matter. The other part of the fundamental theorem of calculus. The definite integral from a to b of the function f of x dx is the antiderivative of b minus the antiderivative of a. Is it helpful for your brain to not just have these letters memorized, but the meaning behind it? Would you guys say the definite integral from a to b? Would you say of the function or of the integrand f of x dx? Would you name this the antiderivative so the capital F doesn't matter to you, the fact that the antiderivative matters of b minus the antiderivative of a? Anyway. It says that any definite integral of any continuous function can be calculated without taking limits, without calculating Lehman sums, and often without effort. Did anybody feel that one? No, just me? I need to get you harder integrals then.
No.
And often without effort. Oh, they're coming. No. So long as an antiderivative of f can be found. Okay. Do you see that? often without effort, so long as an antiderivative of f can be found. You can imagine what it was like before this pyramid, before computing machines. Calculators, computers, Hidden Figures, great movie. When approximations by tedious sums were the only alternative, for solving many real-world problems, then you can imagine what a miracle calculus was thought to be. If any equation deserves to be called the fundamental theorem of calculus, this equation is surely the, okay, do you see it? Our book, the second one. Anyway, whatever. The first, the second, doesn't matter. They're both important. They're both pretty crucial. And they saved a lot of time, so long as, do you see it? The antiderivative can be found, and so long as the function is continuous on a to b. Oh, they didn't say that. I said that. Did you catch it? So long as the antiderivative of f can be found, and so long as the function is continuous on the interval a to b. Okay, here we go. So, antiderivative rules. Do you guys know them all? Integral of 0 is a constant. You know that one. Integral of k is kx plus c. Integral of k times f of x. Whatever is a constant. Even the nasty ones, even the ln of 2's or the pi's or the e's, pull them out. Anti-derived. Sum and difference. Totally legal. But once again, what's missing? Are they going to try to trick you? I don't know. Gavin asked me for a reason. I think he was doing homework. I think there was a times. Is there a rule for that? No. Quotient. No. No integration rule. True? Power rule. That's an important one. We've been using it a couple times already. True? Why is n not equal to -1? The power rule would be undefined because 1 over x comes from an ln. I heard different answers. They all put together to do that. Do you have your trig backwards? You're going to have to reorient your brain. We haven't been having to use it a lot this year, right? What's missing? Okay. Inverse. Wait a minute. Do we know how to integrate sine inverse? Not yet. But we do know how to integrate what equals sine inverse. What would equal sine inverse of x plus c? The integral of 1 over square root of a squared minus u squared. Oh, wrong way. A squared minus u squared is sine inverse of u over a. Oh, that's a thing. There are more of them, right? But we can get to a sine inverse, but what happens if we have an integral of sine inverse, or an integral of ln, or an integral of secant, or an integral of tangent, or an integral of, oh, stink, are there a lot of integrals we don't know? I wonder if they exist. They're coming. Anyway, we'll learn how to do it, just not yet. P.S. Are we okay with when the negatives show up? What's the hardest one about when the negatives show up? We should know that it's a C. We should know that it's a C. We should know that it's an S. What are we looking for the negatives? Not what's inside, technically. What's outside, right? The C's still have the negative, but the answers, remember, we're going backwards. Anyway, some of you need to reorient remembering which one's which. Some of you had a way of remembering it last year and you won't forget. Good. The rest of you, we'll retrain our brains. Total area. Total area. Total distance traveled. Some of you are like, area between all of these should be pointing to absolute value in an interval. Basically, the last thing we need to talk about before we go play with the back of our homework spiral. Graph of a derivative. I know that is really cool. Soon the air will turn off and then it will stop getting colder and it will start getting warmer. That will be a very happy day for us all. Total distance traveled. Come on, my brother card people. What's the formula for total distance traveled? We could go from position, but it would be such a mess. So much easier to go from velocity. The absolute value. Right? We could go from positions, change in positions over change in time, and just be like, okay, hold on. I need all the change in positions to be positive. So if the object is moving to the left and is getting negative displacements, I have to like figure out all of those and make them positive. And if it's moving to the right, I can keep them the same. We could go from position, but it's so much easier to go from velocity and take the definite integral from a to b of the absolute value of v to dt. The problem is, how do you integrate an absolute value again? Split it up. Hey, Moses in the Red Sea, let's use it for us too, just in a very different context than factoring. Or is it? How are we splitting? What are we splitting? The bounds, thinking about any places where v of t could change signs, right? So remember how I was talking about, oh, if you're moving to the left, negative displacements, they need to be positive, and then moving to the right, okay, they already are positive, keep them the same. What's in between negatives and positives? I dt, what's in between? Zeros. So what do we do? Well, I think I have a hint here somewhere. Let's say, for motion, we would split up at the stopping points. Why am I saying stopping points, particularly for this example, or for this application? The stopping points are when the velocity is 0, and when the velocity is 0, it's the possible places where velocity could change from positive to negative. Movement right would be separated from movement left. Does that make sense? So aka when velocity equals 0. So, we have a situation right below. But wait, it's not velocity. Okay, yeah, it's the other way of asking it. It's total area. Okay. So, how do we apply the whole total distance traveled forever card you should already have memorized to total area? Do the same thing. So guys, what's my integral? Just pause. Isn't area beneath a velocity curve total area, accumulated area, regardless of sign, area? Isn't that the change in position or the total distance traveled? Total area, accumulating it all, keeping it all positive, that is total distance traveled. You can think of it that way. Would some of you like to make a graph and figure out where this all hits? Sure. If you're a super visual person, you can make a graph of your parabola. You can take the derivative, you can find the minimum of it, find the zeros of it with factoring. You can think about the graph. For the rest of us, can we just find its zeros, please? I factored out a 3, I divided it to the other side, I factored my x squared minus 1 to be x plus 1, x minus 1, and then I found the zeros. Are any of them going to be O? How many of these fall in between my interval? Which means I need to go -2 to -1, -1 to +1, +1 to +2, or think about symmetry. David was there, he was mouthing it. Think about symmetry. What kind of function is it? Even. What can I do with even functions? Centered around 0, where the bounds are the same distance left and right. Anybody like going from 0 to 2 over going from -2 to 2, especially if I'd have to split it up at 2 different bounds? Does that look nicer? Maybe that whole symmetry thing is actually there for a reason. Anyway, now how do I split up? Now I don't have to worry about the -1 anymore, but where do I still need to split it up at? So I'm going to go 0 to 1. Wait, can I take an antiderivative? Because I'm cool like that. How about x cubed minus 3x from 0 to 1? I only have part of it, right? 0 to 1. Addition or subtraction? Plus, because that's part of the area, I need to add the rest of the area, right? I'm not doing FTC. Just accumulating. Okay, cool. You guys agree with my antiderivative? We're doing some funny things today. Is this going to make it right? I just split up at the bound and that's all I have to worry about? You split up, right? And after you split up, what do you need to do? One big ol' absolute value? No. Because then you're going to have negatives and positives, and they're going to take away from each other before you make it all positive. Split up and make each evaluation piece positive, right? Split up, and then add the absolute values of each of the individual or separate intervals. Are we okay? Oh, even. This is a parabola that's technically centered around-ish 0. So the area that's going to be on this side, whatever it is going to match the area on this side. And so I can just forget him, take him, double. See it? And that way it just makes my work a little bit easier, because doubling is a lot easier than having to do 2 more antiderivative steps. It's because I just saw the vertical shift. There was no horizontal shift. There was no like x term that would move it. So I said, oh, it's just a parabola still on the y-axis. So I used the graph. So you could have also figured out its max-min or its vertex. Derivative is 6x, which has a critical number of 0. Its max-min, its horizontal tangents at 0. It hasn't gone anywhere. If the bounds are symmetric about where it's on, like about the 0, let's say it was a 3x cubed minus 3 from -2 to 2, the answer would be 0 if there weren't absolute value. But absolute value says, well, even if you're odd, I don't care. I'm flipping you up, so you're going to match 2, so it actually would be 1. I think that's accurate, right, everybody? Odd cancels out, so if it's absolute value, right, then it would double. Yeah. Have any of you guys gone ahead and solved it for me? No? We get 1 minus 3 is -2 minus 0. That's -2. And then we have 8 minus 6 is 2. 2 minus 1 minus 3 is -2. 2 minus -2 is 4. And then I think we end up with, okay, absolute value, that's 2. Absolute value, that's 4. That's 6. That's 2. That's 12. Anybody beat me? Match it? Good. So, split up. Maybe using some symmetry clues, if possible, not always. Make it a little bit easier, but then solve with the absolute value of each piece. Guys, check it. If I had taken these absolute values out and totally forgotten and still split it and done so much good math, but then I said -2 plus 4 is 2 and 2 times 2 is 4, I'm off. If I do the absolute value late, it doesn't make a difference. It's not the right difference. I need to make sure that each of these separations, each of these pieces of the journey are made positive before being put together and then getting invited. What's going on with this guy? Well, why is this in the total area, total distance traveled section? Do I have any negatives that I have to make positive? No. What do I have to do? Split it up. Yeah, I have to split it up and add them, right? So what do I have? Oh, no big deal. It's like a quarter circle and a triangle. A trapezoid? No, look at your functions. Is this a quarter circle? So you would need your square root of r squared minus x squared to be a circle, right? This one, we know it looks linear, but it's curved. It's an x squared. So how are we going to split this guy up? Let's not solve it, but let's at least express it. What would the area be? The integral from? I think power rule, right? 2/3 x to the 3/2. Ooh, some of you have to remember how to actually solve. Oh, it's a 1 and a 0. You're lucky. But remember, 3/2 is the same thing as x cubed under a square root. Exponent rules is a thing. Algebra is a thing. Okay. Plus, but good, AJ, you're right. Plus adding more area, right? What's next? We're good?
Yeah.
Just another context of when you might need to split up integration. Okie dokes. So is there anything else? Are we done? Ready, set, go.
Well, we couldn't have, are you thinking like geometry? Well, the limit is Ryan, you might get close enough to the right answer to be able to match it. Probably won't be precise though, just because it looked linear to where you could actually just add the units using some of the geometry sets to find those areas. But x squared is truly curved, and so it's yeah, right? It looks linear. I totally agree. I was like, oh, trapezoid, semicircle. Oh, then I saw the square root of x and the x squared, and I'm like,
It was slight.
it was like, I'm gonna start playing in just a second. Leave me there.
Hopefully you're splitting up at 2. Right? Anti-deriving, solving separately, taking the absolute value of the fundamental theorem of each piece, the evaluation of each piece. There's no symmetry about 2 for this one, sorry. Those absolute values, though. Hopefully you knew piece by piece, but those absolute values did not affect anything until I fully evaluated FTC. Fully evaluated FTC. Fully evaluated now. Because the 9 halves minus the 4 is f of b minus f of a. That does not change. I have to say 9 halves minus 8 halves is 1 half absolute value of that. I have to do f of b minus f of a. Find that and then evaluate it or change that. Does that make sense? Mm-hmm. Wow. Good. Cool. Okay, back in your homework spiral. But in your notes, if you want to go ahead and refer to this, what this example is showing us is an antiderivative that's been given graphically. An antiderivative that's been given graphically? Wait, you said this was the graph of the derivative. Wait, what? antiderivatives with a graph. You guys know that AP loves to give you accumulator functions. Remember, we're using that vocab more this year. Accumulator functions. We're going to zoom in on this example. Given a function defined as an integral. Given a graph of a function who's defined as an accumulator. So technically, we can say given an accumulator, right? Okay, you guys already have this written down, so you don't necessarily need this to be like super big and blown up and all that sort of jazz. Let me go ahead and get an extra page so I can play, as far as having room to play. We have capital H being definite integral from 0 to x of a function. Oh, this is the integrand. The integrand is being graphed. Integrand. What's the integrand? It's okay, we'll get there. Alright, well kids, we're just going to work on it together and hopefully finish up by the end of class. Sound good? This is the end. And number 58 is the reason why I was like, oh yeah, let's do some more examples. Make sure you're good, and then homework's due tomorrow. H of 0. Whenever we start plugging and chugging to an equation, don't we have to plug in every time there's a 0? I should say every time there's an x in that equation, right? H of 0. Where's my x? There he is. Where's my x? There he is. Hey, what's the integral from 0 to 0? Okay. Letter B. Take the words, model them with math. What am I really trying to look for? Where H, who? Oh, model it with math. H prime of x is greater than 0. Okay, so hold on. I have a graph of f. So how do I get H prime in terms of f? Can't I take a derivative of h to get h prime? Right? Derivative of h prime. Derivative of the integral from 0 to x of f of t dt. True? H prime, see it? H prime, H's derivative is the derivative, that's FTC part, whatever you want to call it, but the derivative from a to x of f of t is f of x. Okay, so I'm asking, where is f greater than 0? Oh, easy. If you can read the graph, beware the open and closed intervals and which one to use. Close bracket. Starting at? And going to? And then? Got him. At 6, my function is 0, not greater than 0. But at 0, isn't my function 8, which is greater than 0? The function started up, so close bracket at 0. Ended at 0, which is not greater than 0, so close it. Sorry. Let's leave it open. Apologies. Letter C. Model it with math. What am I pondering if I am given the question? Where is H concave up? Good, but state it simpler first, Lorenzo. So H concave up, we go straight to the forever card and we know in terms of H. So why was Lorenzo starting to talk about F? Because we have to, right? Hold on. So go look at where the relationship is. Oh, it's right there. Okay. How do we get to H double prime? All math that you would put in this section of the free response so they saw the math occurring, right? Some of you who graded, oh, you haven't done that yet. BC kids grade the ABFRQs, right? And you get to see all those mistakes that you guys made last year over and over and over and over again. And guess what? Accumulator functions? Oh, so many mistakes. It's so easy. Okay. Isn't h double prime the derivative of the derivative? So what's the derivative of the derivative? They gave you a point just for saying that. Just for saying that. Coming back. Oh, my marker cut out. Oh, it's still cutting out. Ah, there you go. Because the derivative of the integral from a to u is f of u times d. Does that make sense? Which is why we just looked for where he's above, not at his behavior. We're looking at that now. Before we were just saying, oh, when's the up? Oh, okay, from here to here. But now we're, oh, I just gave it away, didn't I? Because now we're looking for where f prime put the comma before which, right? Which occurs when, now, this is more for your visualization than for the actual necessity of answering or explaining or justifying what the answer is about to be. For your visualization, the first derivative of f will be positive when f is doing what? Increasing. Doesn't that make it so much easier? I don't want to say which occurs again. That's annoying. Which occurs when f is increasing on that qualifies. I mean from
When
so I'm not trying to say this only happens. Probably doesn't make sense in your head. When f is increasing. I'm just going to put parentheses. 4 x is within. Awkward. The AP would have done a much better job because can you guys tell that when does it increase?
9.
Exactly. That question mark that you just gave, the AP makes it you never have to question mark, right? They do little dotted lines to show exactly where it is. They state something about like, hey, there's an HTL at these points. They make it precise. This one doesn't. That's why this is a textbook and not an actual College Board release. But yeah, let's go ahead and say 9. That's fine. 5. Let's freeze because that's fine. Okay, whatever. 9. Okay. Open or closed?
Open.
Good. Open or closed? It would be closed. What is the slope at 12? It's positive. Does that make sense? It's not leveling off. That's not a horizontal tangent. There is positive slope there, which means my function is increasing. Letter D. H of 12. Don't stress about going straight to the graph. Why not just plug it in and say, wait, you're talking about 0 to 12? Oh, wait, you're talking about area? Right? So visualize. Hey guys, look at all that. Hey guys, look at that little bit. Who wins? The positive and the negative? Explain. Since, can I do this? The integral from 0 to, what does that intercept? 6 of f of t dt is greater than 6 to 12. Should a mathematical person understand I'm saying the positive displacement is greater than the negative displacement? Go team. Where does h achieve its maximum value? I want the max and the min for e and f, right? I want the max and min of h. Don't I need to think about critical numbers and endpoints?
Yeah.
Right? Critical numbers, that's when h prime, oh, which is f, is equal to 0, which only occurs at 6, right? There's my critical number. Oh, don't I also have to consider? Considering remember, they like it when I explain the endpoints of 0 and 12 and the critical number of h at 6. Oh, stink, I just lost my breath. I need to think about, wait, isn't h just the accumulation of area starting at 0? So what was h at 0? Oh, why? Why are you gone? I don't understand. Sorry, computer. Fun times. Not really. Okay. What was h of 0? We found it in letter A. He's 0. Well, he's not very high. What's h of 6? So I'm testing my critical numbers and my endpoints. If you want, we could do a little like, hey, I want to know what's going at 0, at 6, and at 12. H of x. At 0, he's 0. At 6, he's a positive. Okay? At 12, he's a positive, but a lower positive. Without using all the words in this now, this, that, and the other. Because wasn't there negative displacement, right? So positive with some taken away. He's still positive, but he's a lower positive. Okay, where's my min occur? My min is at 0, because he's the, those are positives, yeah, he's lower. And then where's my max? Because he's my highest positive. Okay, I talk about how my h is strictly increasing, strictly decreasing, and absolute max is going to have to occur at 6. And because my overall change is a positive, therefore the 0 will be lower than the positive value at 12. Yes, I could use wording, I could explain, justify, all that jazz. But do we have the idea? I think so. Kiddos, I think we are. I think we are. Yes. Now homework is due. Sound good? Yes. Happy Tuesday. I'll actually be here today after school at least for a little while, and I will see you guys later. You have 15 seconds to relax. And then you have a whole lunchtime to relax and eat some more. Eat, and relax some more. Bye guys. Bye Dean. Bye Gavin.